Good afternoon, everyone. I'm Bermudez.
And I'm Marc Pamintuan.
And I'm Bucal, and we will talk about Weka. Weka is a collection of machine learning algorithms for data mining tasks. The algorithms can either be applied directly to a dataset or code from your own Java code. Weka contains tools for data processing, classification, regression, clustering, association rules, and visualization. It is also well suited for developing new machine learning skills. Ngayon ipapakita ko sa inyo kung paano i-install yung Weka. Una, kiklik nyo yung application ng Weka na dinownload nyo. Sunod, magpo-prompt siya ng admin. Tapos nakatanong dun kung do you want to allow this app from unknown publisher to make changes to your device. I-click nyo lang yung yes. Yan. Tapos ito na yung wizard. Ina-next nyo lang din yan. Tapos dito sa agreement, mag-agree lang kayo dyan. Ina-next nyo lang din to. Tapos ito, kung gusto nyo sa ibang folder ilagay, pwede kayong pumili. Pero pwede na sa akin dito sa drive C. Kaya ina-next ko lang din yan. Kung gusto nyo rin, may shortcut kayo sa Windows nyo, ayan, pumili lang kayo. Ayan, click nyo yung install, magsisimula na siya. Medyo matagal. So ayan, complete na siya. Next nyo lang. Tapos finish na.
Weka have many platforms like Windows, Mac OS, and Linux. If you want to download the 64-bit Windows with Java VM, you can click it here. But first, go to this website first. Then, without Java VM, click the button here. And for 32-bit Windows, you can choose if you want Java VM or without Java VM. In Mac OS, click here if you want to download the Mac OS version, and here for other platforms like Linux and etc. In software specification, the requirement is Java 1.1 or later is required to run the Weka, a data mining tool. Depending on your computing platform, you may have to download and install it separately. And in hardware specifications, there is no requirements.
So as a default, you can see that there's this blue outline on the button, making Explorer the default application. Then there's this experimenter, which focuses on performance comparison. The knowledge flow is for graphical interfaces, while the workbench supports and facilitates range of machine learning activities, reducing or removing the need of multiple tools. Then the simple CLI is for the command line interface. So for now, we're going to choose on Explorer. So as you can see, this is the environment of the Explorer. There are these 6 panels. 5 of them are grayed out, and these are classify. And classify is for building classifiers for your dataset. And then there's these clusters, which Weka is very good at making clusters for your datasets. Next, there's associate, select attributes, and visualize. So to start, we're going to click on open file. We're going to get a data. First, go to the Weka datasets. Then, as you can see, there are these sample data which we can use for our demo. For now, we're going to click on weather nominal, ARFF. Okay, upon clicking open, you will see this 14 instances representing the days for our weather dataset. And on every day, you can see there are 5 attributes, namely number, name, label, count, and weight. So on the attributes of name, as you can see, there are these 5 attributes: outlook, temperature, humidity, windy, and plain. So on the outlook, as you can see, there are 3 variables which has count, and if you add all of these, you will arrive in the number of the instances present on the data set. And on the outlook, there are 3 variables: sunny, overcast, and rainy. Temperature, there is hot, mild, and cold, and so on. And if you click on play, you'll see this yes and no label, which yes represents this blue bar or bar below. See that? 9, yes, and then there's this 5, which means no, which represents a red bar. So if you look at outlook, you'll see that there is this red bar and a blue bar. So it means that in 5 there are 3 no's and 2 yeses, and in 4 of the overcast, you can see there are 4 yeses. Okay. Next, we will go to edit to see the overall look of the viewer. I mean, on the data set, and then here you could actually change data of the variable by clicking on it and changing it. So keep in mind, if you want to undo it, click here, but if you really want to change it, click on OK, and then if you want to save it, click on save, and then click on save and override yes, and that's all. So we are done with the nominal values, and now we're going to go to the numeric ones. So we're going to open the file and check on the weather numeric. So as you can see, it's like the same file about the nominal, but the difference is there's this numeric values. You can see example here is temperature. So you can see the minimum is 64 and the maximum is 85. Okay, let's go deeper. Let's go deeper on numeric types. So let's go to gloss. Okay. So as you can see, there are instances of 214 in this data set. So as you can see, there's this refractive index of a glass, which is set to the minimum of 1.511, and this is 1.534 as in the maximum. And here, as you can see, if you remember your chemistry class, and A, sodium, Mg, magnesium, these are the components. These are here the components of the glass in this data set. So as you can see, this is the types. Okay, as you can see, there are 7 variables in the attribute type. So there's 1, 2, 3, 4, 5, 6, 7, and this corresponds each color. So here you can see there's this building wind float, building non-wind float, vehicle wind float. It's all about glass. Okay, so as you can see, there's this nominal weight and the count for each. And now we're going to look at sample is sodium. As you can see, the graph has values, which of each type here represents values in here. As you can see, there's the minimum, the maximum, and it's graphed there. So we're just having a reality check here if there's something wrong with the minimum maximum of the glass. Example, if aluminum has more than 0.28, I mean less than 0.29, there can be some effects, so we must be careful about that. So we're going to check here if everything is okay. So you can see that, and here you can analyze data, the composition of a glass, and how much is in there. for example, if there's too much sodium, what can we do about that? So it's the composition of the glass. And again, on edit, you can see this the overview of everything in there. See that? So now we're going to check on the source of the data set. So we're going to go to the glass. Open with the app. So here you can see the comments describing what the data has. There you can see that it's glass identification database. And you can see that there are these attributes, instances of 2014, and there's the ID of 124 to 100 to 2014. As you can see, that there are these names which corresponds to this chemicals. And see, there's a type of glass we've seen earlier, and here are the summary statistics here. So if we go lower, you can see that there's this code. This is what the Weka reads. So relation glass, the attributes are here, saying that these have numeric values, and the bottom type is type, and it has these types here, and each of them of type has this data below it. So that's what our Weka program reads in a data set. So now we're going to check on the classify panel. Mainly we already chose a classifier, but on Weka there are several types of classifiers, mainly base, functions, lazy, meta, and others. So now we're going to check on sample J48. So we click on it and see what it has. Click on start. Okay, these are the data that are in the classifier of glass. As you can see, there are instances and other types. Okay, you can see the tree as we chose it on the tree folder. There's this trees. Okay, a tree, and then there are a number of leaves and size of tree. Size of the tree or the instances on the tree is 59. Okay, summary: the correct classified of instances is 66%, which is pretty good. Okay, more data of accuracy, and now we go to the confusion matrix. As you've remembered, we a while ago we've seen the type, and there are these values, and as you can see, there's this diagonal numbers. Here on A there are 50. Yeah, the other numbers here are misclassified, and as you can see, there are numbers around which are really belonging on its class. So those are the misclassified values, while the diagonal is the correct ones, which are classified correctly. So next, we're gonna click on the name. We're gonna try unpruned, putting it into true. Okay, click OK, and if we click start again, you see a slight change from the trees are now pruned, making it at 67% correctly classified instances. Now we're gonna go and click it again on the minimum number of objects. We're gonna go from 2. It's the minimum number of instances per leaf. We're gonna go from 2 to 15 to make a smaller tree. Click OK and start. See, again, everything changed, and as you can see, the numerically classified instances lowered, but as you can see we have a smaller tree which is easier to analyze. So lesser percentage but a smaller tree. There. And now we can actually look on how these things are in a tree. For example, if we click here on the last one, right click and go to visualize tree. As you can see, it's make it bigger. If we fit the screen, it says here, if this element is less than, it's greater than or equal to. If it's less, if BA is less than or equal to 27, you will go and to look at the magnesium. If it's less than 2.4, you check on the chemical chemical thing K, and check if it's less than 0.12, it's a tableware. If it's greater than 0.12, it's a container. So, and goes on if you check every value of the tree. Okay. So now we look for, if you click on more, you'll see more more detailed data explaining the classifier J48. So now we're gonna go to check on filters. So first we're gonna go to Weka databases again, and so a filter is like, it makes the data smaller, making it better and easier for analyzing data. So example, we're going to choose filters. We go to unsupervised filters. For now, the example, we will remove humidity from the attributes in order to make a smaller sample to analyze. So we're going to go to unsupervised. It's an H attribute, and we're going to check and remove. So there you go, it's already there. Left click, and for the attribute in the indices, we're going to go to 3, which is number of the humidity, which is 3. Click OK, nothing happened until you click apply. While clicking apply, there you go, humidity is delete. So now I'm going to do, actually there's an easier way to delete it without using filter. Just click on check and remove. But I'm just showing you how filter is being used. And there are a lot of operations you can do on filter. So here. Now if you want to remove high, which is a count of 7, well, if you remove this, the instances will diminish. So to do that, we're gonna go to humidity. You gotta go to remove, choose, and then look for the instance, which is the instance of the attribute. We want to remove the high value. So remove the label and the count. Okay, so left click here, you're gonna put on the index which is 3 for the humidity, and on the value of the attribute here, I'm gonna go for 1 to remove this. Click on OK, and to apply, for it to happen, click on apply. There you go. As you can see, high is now at 0. Actually, you can do this on, let's open another file for a better one, gloss. If you click on, last time, you've already seen, if you click on the tree of the glass, start here, again the tree. So if you go to click on it. Sorry, here. If you remove things like something here, first look at the correctly classified instance percentage, which is this. This is the chance of having a correctly classified instance. If you look at here, if you remove values, let's take for example, if you remove just if you remove them and you could classify and get another one, you'll see that your instance had a higher rate of being correct due to the data that you have been removed and will be disregarded in the analysis of data. So if you look at the tree, visual tree, same results, but the lesser, it will have lesser values due to the removed things, I guess. Thank you. So for visualization of data, we're gonna go and look for the data set again. We're gonna go for iris. Here you can see sepal width, sepal length, petal length. Now we're gonna go to visualize. So we're gonna check somewhere here, x and y axis. Example of this. These are the data in the data set of the sample iris. So as you can see that each of them represents a data, and below here you see there's colors representing what that data is. Actually you can change the color but it stay the same. And if you move jitter, as you can see some of them having overlapping data. So example here, if you click on it, there will be two data in one place. Okay, so that's visualization of data. Now we're gonna visualize from the classified panel. So we're gonna choose trees and again J48. Start. Now we will right click and go to visualize classifiers error. And now you will see this boxes here where you could click on and you will see data in here. The error is it is class versicolor, but its predicted class is Virginica, so that's the error. The same as goes on the other one. So if you click on rectangle and you look at here, if you drag it here and you click submit, you will have a zoom in view of what you have just highlighted here, for example. So it will be easier for you to visualize data that you have in your data set.
That's all for today. We hope that you have learned something new from our discussion about Weka, a data mining tool. And again, I'm Marc Pamintuan.
I'm Bermudez.
And I'm Bucal.
Thank you for listening.